I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, February 15th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights to the North Pacific Ocean, we see an area of called disturbed weather with 20-foot seas off the coast of Oregon, not really doing a whole lot. A gale or a low-pressure system trying to develop over the dateline, and another system trying to build off Japan, but nothing very impressive at the moment. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When the gales form, help direct their track. We're looking for a trough, a dip in the jet, just like that right there. What that helps do is create a counterclockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. And low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a trough on the dateline offering a little bit of promise. There's decent winds. What is that? 160 knot winds pushing down into the western quadrant of the low, and then nothing down at the bottom, and then another fetch, or not fetch, but a area of winds to 150 knots over on the other side. So there's a little bit of support for gale development. But what you also notice that this, as we get into Tuesday, quickly starts pinching off and falling apart. The wind dissipates, so that's not good to help support gale formation. Winds continue off Japan in about the 160 knot winds, 160 knot range. And also notice what we call a ridge. It's the opposite of a trough. When the jet is bulging to the north in the northern hemisphere, that creates a clockwise flow aloft and down the surface. That's the hallmark of high pressure, and generally doesn't do much for surf production. All right, so not a particularly promising pattern as we get into Tuesday. Wednesday, pretty much the same. All the energy right here in the middle of the Pacific just completely falls apart. Good cohesive jet pushing off Japan with winds to 190 knots, but notice the jet splits. Half of it heads deep south, the other half off to the east. And when you get that split jet stream flow in this big blue pocket in here, that typically means high pressure. So we continue, but also notice the jet falling south inland. Cold air on this side, probably warm air or warmer air on this side of that. This is a trough. It's over the central U.S. Right. Oh, also notice, go back right there we go. 210 knot winds right off Japan as we get into Wednesday night. Strong, and a bit of a trough trying to organize here over the Kuril Islands and Kamchatka. And another little bit of a trough trying to organize Thursday night up here in the northern Gulf. Continuing into Friday, but that the trough in the Gulf pretty much pushes inland, not doing a whole lot. And this trough heads well north. The split point still like right on the date line. We need the split to move east of the date line, but we don't think that's really going to happen. As we get into Saturday, sort of pretty much the same pattern, a bit more energy pushing into the northern branch of the jet, but still well split, high pressure between the two. None of this looking particularly favorable. So you get into Sunday, even the jet off Japan starts weakening, and you see it almost looks like it wants to split. The split point moving back here to like 165 east. Where are we at? We still have a little bit to go. And then even weaker, we're getting towards the springtime pattern. Here we go. Split point 165 east. It's like split here, and then the southern branch splits again, and it tries to come together off of British Columbia, but not a whole lot going on. Just a very weak jet stream flow, pretty typical of what you'd expect during La Nina. All right, let's go take a look down at the surface. Here we go, surface level pressure, surface level winds. The gale, there is a gale over northern Japan, pretty much landlocked though. A little bit of fetch pushing off. Again, winds rotate counterclockwise around low pressure. So you get, was that 35, maybe 40 knot winds, even 55 knot winds over a tiny little area off Japan, but not getting any big extent into the Pacific Ocean. We know there's another low here and a trough trying to organize here. Wind's pretty weak, 25 knots, maybe 30 knots. Then another little low off of, or over Vancouver Island, not doing much. And you get into Tuesday, and all this pretty much falls apart other than the low, still landlocked over Japan and the Kuril Islands. Wednesday, not pretty much the same. Now, there is a gale forecast up here, but notice all the fetch is heading due north of Alaska. It does nothing for really our forecast area. Continuing to look as we get into Thursday, still nothing. Broad low pressure over Japan, but just goes nowhere really. Bit of fetch trying to develop over the dateline, but it's all aimed to the north. A little bit of a low in the northern Gulf of Alaska on Friday, but just not doing much. Then we get into, let's say, later Friday, a broader area of 35, maybe 40 knot winds develop over this broad area of low pressure over the, we'll call it the Aleutian Islands. But winds are only 30, 35 knots, and this fetch is aimed northeast, not even really at the U.S. West Coast. So we're into Sunday now, still really nothing. High pressure in control off of, or in the Gulf of Alaska. Continue to look for anything that smells like a storm, and really nothing happening. All right, let's go take a look at the wave models. We're going back in time to Tuesday night of last week, almost a week ago. A little gale did develop here on the dateline. It pulsed and then reorganized on Wednesday, producing about 42, maybe 43 foot seas here right on the dateline. That swell has already hit Hawaii and is on its way down. And it arrived in Northern California yesterday. That was on Sunday. And there were some solid 10-foot sets, maybe even some bigger sets. But that swell is fading today, Monday, and of no real interest. We're watching this just to get us sort of up to speed. Any swell that's in the water was generated by this system, and there should be continue to be surf relative to California for a couple of days here. The real issue is going to be wind, but we'll get into that in a minute. All right, let's look forward. So here we are, 18Z on Monday. Again, our little gale off of the Pacific Northwest and pretty much nothing else. Given what we saw on the surface level charts and wind, all we expect to see is maybe something in this area and maybe something up towards the Aleutians later in the model run. Yes, there is almost 30-foot seas there, all aimed to the north like what we saw on the wind models. So you can quickly see the correlation between the wind models and the wave models. You got to have wind to have waves, and the wind has to be aimed in the right direction. So where are we? We're into Friday night, pushing into Saturday. Fetch over here, pretty much aimed northeast, but sideband energy probably down to theoretically Point Conception. This is for Saturday, so that's 4 or 5 days from today. So this hasn't even developed. It is a theoretical fetch and theoretical seas. We're into, what are we here? Monday. We're almost there. Just looking. Oop, that was it. So maybe some hope towards the weekend in the northern reaches of the Gulf of Alaska and out in the northwestern Gulf of Alaska. But nothing really solid. Of note, down south a week ago, a gale did develop in the far southeast Pacific, 28-foot seas initially, then a secondary fetch, right there produced some 30-foot seas aimed north into Monday, and then a tertiary fetch came in behind that, generating more 30-foot seas. Swell is in the water, expected to arrive in Southern California, I believe it's tomorrow, and hold for a couple of days. Nothing huge, but rideable at the most exposed south-facing breaks. North of there, though, north of Point Conception, probably any of this swell will be buried completely in the larger swell from the North Pacific that's currently hitting. We'll take this model on out. Another little gale here developed on Saturday. That, again, could produce some surf, more of a, we'll call it a south northwest swell, but not a New Zealand swell. And then let's look forward. And then here we go. Here's today. We're just going to blast through this, see if there's anything. A little bit under New Zealand, 28-foot seas. That's not much. That's maybe good enough for Hawaii, but doubtful for anything for the U.S. West Coast. Notice when you see storms falling to the south or weather system to the south, that's not a good sign either. They need to be radiating or pushing up to the north. So, and that was it. So, one swell in the water, expected to arrive on Tuesday, good for a couple of days, and that's probably it for now. Maybe a little bit after that, not much. But it sort of hints at maybe we're starting to approach the seasonal change. More to follow on that. All right, back to the North Pacific. Local wind forecast for Hawaii, U.S. West Coast, high pressure, 1028 millibars in control of the called the southern Gulf of Alaska, generating a northwest flow into North and Central California, and I can't call it trades. South winds relative to the Hawaiian Islands, not too strong. Core of the high right in between the two. As we get into Tuesday, stronger north winds along the U.S. West Coast, Southern California protected. Southeasterly flow continues for the Hawaiian Islands. Wednesday, more of the same, pretty much our tattered mess relative to California. Light trades for the Hawaiian Islands. This high pressure here, though, looks not good for Hawaii in the immediate future as we get into Thursday. What do we have? Still trades for the Hawaiian Islands. Oh, the high's mellowing out, so maybe Hawaii will do okay. California, a weak front setting up Thursday night off the Cape Mendocino coast, but it pretty much washes out. High pressure here, strong, well not strong, but building trades for the Hawaiian Islands, 15-20 knots, and a light northwest flow on Friday relative to North and Central California. And then as we get into the weekend, high builds in, stronger high pressure on Saturday, strong northwest winds along the whole north and central California coast, pretty strong trades for the Hawaiian Islands, 20 knots. Get into Sunday, trades or north winds mellow out a bit relative to California. We'll call it 10 to 15 knots. Trades persist, 20 knots for the Hawaiian Islands. And then into Monday, a lighter wind regime for California, but still pretty good trades for the Hawaiian Islands continuing into Monday night. Looking at rainfall potential for California. So here we are Monday evening. Light showers, some sprinkles every now and then, maybe a little bit of very high elevation snow for the Sierra, but temperature's pretty warm. In fact, we were looking at Squaw this morning. It was like 36 degrees down at the base and even 33 degrees up at 8,000 feet. And everything was on wind hold above 8,000 feet. So pretty much a soupy mess is our best guess. Probably not, whatever snow there was, very wet snow. All right, moving into Tuesday, Wednesday, we're just looking for anything here. We're not really expecting to see it. Then finally, as we get into Friday, that little front that dies off the coast produces some rain, a little bit of snow into Tahoe, rain down to, call it Monterey Bay, and snow maybe down to Yosemite. Yeah, even further than that. By Saturday, we think that all starts clearing out, high pressure in control, and that's pretty much the end of it, and nothing is expected after that in terms of precipitation relative to California. Snow dashboard, yeah, maybe another inch or two or something like that overnight for Tahoe, then nothing. And then on that was that Thursday night, Friday storm, maybe theoretically a foot and a half, but that's probably on the optimistic side, and then nothing after that. Notice the snow levels reasonably cold during the week, but then you get into February 21st and the freezing level, that's where the gray turns into white here, goes up to, what is that, about 10,500 feet. This is the top of Squaw here. This is the base of Squaw. So if you were to get precipitation, it would be liquid precipitation the whole way to the top. And then as we get later into like the 24th, 25th of February, things try to get a little bit better. But this again hints to that suggestion that, well, if the temperature's rising, maybe we're moving towards more of a springtime pattern. The other thing is batches of northwest winds along the California coast. Pretty typical of La Nina. You get that strong high pressure like we saw on some of the charts building off the California coast, creating north winds. That'll create a bunch of upwelling, drive water temperatures down locally a bit, makes for wind swell, but doesn't do anything for real swell generation. You see the whole Pacific longer term looks like a high pressure regime trying to set in. Low pressure, split jet stream flow, all that is typical symptoms of La Nina. Let's go take a quick look at Kirkwood and then Mammoth. Kirkwood, pretty much the same deal. Another inch or two of snow overnight. And then maybe a foot and a half on the Thursday, Friday event, and that's it. Temperatures, a little bit better. This is the base of Kirkwood. This is the top. Still, when you get to this warm bulge out here, above freezing temperatures the whole way up to the top. So you're supposed to get, you can see the blue. That's the fresh snow. So you get your snow, or right here where the yellow is. And so you're good for, what is that? Maybe the February 20th, but then 12Z on February 21st. That's 4 a.m. on the 21st. And your temperatures are already quickly coming up, and whatever fresh snow you have is going to turn to set up and get pretty slushy by, mid-afternoon, maybe noontime, and after that, it's over. And then Mammoth, no more snow, effectively, and then maybe, what's that, 3 inches, 4 inches from the final event on Thursday, Friday. And this is the base here, and the top, even the top on this event, still just slush. The gray's like slush, not freezing, but when you get 33, 34 inches, especially if there's colder air aloft, you can get snow, but it's really heavy and wet and slippery and not particularly good quality snow. Of course, the other thing is, models this far out can change a lot. We've seen this before with these big warm-ups or forecasts, and the closer you get, you see it's not nearly as bad as what it appears. So, hard to know whether this is a springtime warm-up or what. We'll give it a couple of days and see. All right, let's go take a look long-term. What's going on with the Madden Julian Oscillation and, of course, La Nina, or the El Nino Southern Oscillation. As usual, we like to first look at the MJO, the Madden Julian Oscillation. It's a periodic weather oscillation, travels on the equator from west to east, and has 2 phases, active phase and inactive phase. Both phases take, a couple of weeks, 4 weeks to get across the Pacific. When the active phase is traversing the Pacific, it acts like a big low-pressure system. It imparts energy to the jet stream. It stomps on trade winds, reduces them, or can out-and-out reverse them. Successive active phases can take warm water, since they reverse trade winds, take warm water in the West Pacific here, push it to the east. That can kick off El Nino. And the inactive phase typically follows the active phase. Again, it takes 4 weeks to go across. It is characterized by high pressure. It steals energy from the jet stream, causing the jet stream to split, increases trades, and does nothing for supporting El Nino. If anything, it feeds La Nina. All right, so this is the West Pacific here. This is the East Pacific here. This is the equator. We're looking at these arrows. The colors are temperatures, ocean surface temperatures in centigrade, but we're ignoring that for the moment. We're looking for the presence of the active phase of the MJO because when it feeds energy to the jet stream, it also helps feed storm production. Right now, winds are out of the east, not horribly strong, but moderately strong in the East Pacific. Same thing over the Central Pacific. And in the West Pacific here, we call it the Kelvin wave generation area because when the active phase is over here, and when it's strong enough, and when it reverses trade winds, it can take this warm water here, start pushing it to the east. Successive active phases can help kick off El Nino. All right, but we're seeing pretty solid easterly winds over the West Pacific too, suggesting probably not the active phase in control. But it's not the actual wind speeds, because the winds, these are 5-day average winds. Winds, they change depending on the season. There's a seasonal component. So we look at anomalies, differences from normal for this time of year. Okay, so we're late winter, maybe early spring, pretty strong easterly winds. We're looking at these arrows here, but they suggest, well, if anything, maybe a slight westerly component to the winds, meaning these east winds aren't as strong as they normally are. Same thing over the central Pacific. And then in the West Pacific, yeah, winds are out of the east, but just barely. So that's probably pretty typical. But no clear signs of the active phase of the MJO, because if it were strong and everything was lined up, these arrows would be pointing from west to east, meaning westerly anomalies. All right, what's the forecast? What's it going to be? Okay, and all we care about is the east-west component of the wind. That's what this chart is, 850 millibar zonal wind anomalies. The blues are stronger than normal east winds, the west stronger than normal west winds. We want to see reds, and we want to see them in the Kelvin wave generation area. So where is that? Well, this is the whole planet on one chart. The date line runs right up the middle there. Okay, so the far west Pacific, the far western boundary of the Kelvin wave generation area is about 135 east. So right there, going the whole way up the chart. And Ecuador is like right here. You can actually almost see a seam in the picture. So that's the far east Pacific. Kelvin wave generation area from here to just west of the date line, or east of the date line, 170. So from there, so we're looking from here to here, and here's the forecast. So you see westerly anomalies at the moment, but easterly anomalies trying to develop, and over the next week, pretty much easterly anomalies filling the Kelvin wave generation area. The one glimmer of hope is, you notice westerly anomalies that have been sitting here in the Indian Ocean for a long time are trying to make a little bit maybe of a push to the east. Not quite getting in the Kelvin wave generation area, but so tantalizingly close. It's a nice little tease, so we'll call that hope. All right, more digging for any evidence of the active phase of the MJO. So what is this? Outgoing long wave radiation forecast. Fancy word for cloud cover. All right, so there's South America, Central America, Mexico, the equator right there. Okay, date line 180 west right there. There's New Guinea there, Australia, the Philippines. Kelvin wave generation area. Far west Pacific, right to 170 west. So a box 5 degrees north and south of the equator right there. And we have blues. Blues mean negative anomalies. That means more cloud cover than normal, less sunlight reflecting off the ocean surface. So that would mean the active phase of the MJO. Hey, I'm excited. The active phase of the MJO is over the Kelvin wave generation area. That's exactly what we want. But the one problem is La Nina and this thing called a high pressure bias. We're not going to get into it right now, but it's basically negating. La Nina is negating what the active phase of the MJO is trying to do. Anyway, so here's where we are. 5 days from now, active phase holds. Notice this massive inactive phase in the Indian Ocean. Okay, and that hadn't happened for a little bit. Active phase holding 10 days out. Active phase per the statistic model almost still in control 15 days from now, 2 weeks from now. Okay, that's per the statistic model. Let's see if we can pull up the dynamic model here. Here we go. And what's it say? Active phase 5 days, fading 10 days out, rebuilding a little bit 15 days out. So the two models here, we'll just sort of do it this way. Here you go. You can see there's a big disparity between the statistic model and the dynamic model. And they have been a little bit at odds long term for a while now. But that still probably suggests that, if anything, halfway in between the two, some sort of weak active phase probably holding here even 2 weeks from now. All right, so next up, same model, statistic model here, dynamic model here, but this is what they call phase diagrams. Gives you a little deeper view of what's going on. Okay, what are we looking at? Well, this circle, assume this is the North Pole. The equator's out here around the edges. And the MJO moves from west to east, from the Indian Ocean, over the maritime continent like Bali, over the West Pacific, to the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so in the West Pacific. And the further it is away from the circle, the stronger it is. So a moderately strong active phase over the West Pacific today. The forecast per this is the statistic model, has the active phase racing to the east and somewhere between extremely weak to moderately strong over, we'll call it North Africa 2 weeks from now. Now, the dynamic model says a variation on the same thing, but with the active phase sort of crashing back over the maritime continent, we'll say Bali, 2 weeks from now. So pretty much all the models are suggesting now that whatever we have for an active phase, it's at its peak right now, and you can see this is the past history here meandering around, or here. They should be theoretically the same because both models share the same starting point. So you see the active phase since, what is this? Is this January? Yes, since 23rd of January. Actually, since the 21st of January. So it's been February, almost, not quite a month. It's been meandering around here in the West Pacific, and now is finally going to make its move. And it looks like crash to nothing, which means it's not going to do anything to help us in terms of storm production. Quick look at the upper level model. So this just shows you areas favorable for precipitation. The greens are wetter than normal. Oranges drier than normal. Consider this the active phase, but it's sort of, the upper level runs ahead of what's down at the surface by about a week. So, and this is South America, Central America there. Equator, 0 right there. Dateline roughly there. There is New Guinea, the Philippines, Australia. So Kelvin wave generation area right here. We'll say the active phase is somewhere over the Central Pacific and expected to move into the Atlantic by the 25th of February. So, a week from now. Inactive phase moving into the West Pacific early March, and all of March, active phase in control, moving out the end of March, with a new active, I did say this was inactive, with a new active phase then building over the West Pacific end of March. So it kind of looks like we have a dead zone here for the next month, and somewhere later in March maybe we'll get an active pulse. CFS model goes out a month. All right, so what are we looking at? Whole plant on one chart. Dateline runs right up the middle. West Pacific, west edge of the Kelvin wave generation area, right about there. East edge of the Kelvin wave generation area, right about there. And that's all we care about. So you can see, and if I actually scrolled up here, you can see when we had all that big surf, and this is not normal, massive easterly anomalies here in the Kelvin wave generation area, but we think that it was actually, the winds were so strong at the surface out of the east, they were feeding into the core of the active phase of La Nina over in the West Pacific, and the outflow from it was blasting out over the Pacific, feeding the jet stream. And this is kind of a very rare event, and that's what fed the storm track. And as soon as that strong inactive pulse ended in the easterly anomalies, like January 17th, the storm machine just shut down like someone flipped a switch, and that's exactly what it did. We really haven't had anything since. All right, so where are we? Here we are today. Again, this dark contour is the active phase of the MJO. It's over the Kelvin wave generation area, and we have some westerly anomalies, but the base state is La Nina. So whatever the active phase is doing, it's not enough. It's just sort of making things neutral. It's not feeding the jet stream, really. And then as we go, well, here's a week out. Each one of these notches here ticks is a week from now. So you can see the blues starting to build, and the dotted contour is the inactive phase of the MJO, with easterly anomalies setting up. So by the 7th of March into the 14th of March, inactive phase takes control. It is in phase with La Nina, so that will only feed the La Nina machine, feed trade winds, probably feed high pressure development over the Pacific, make for some wind swell, but a bunch of upwelling is possible. The long-term outlook. All right, so this is the reverse. What has happened in the past is down here. The forecast is up here. Kelvin wave generation area from about here to about here. Here's that big easterly wind pulse that happened it started trying to get organized in November, but it really got going in earnest sometime in December and went the whole way through about mid-January, then faded, and that's when our surf faded. Now, supposedly, east anomalies are going to set up again. If you just look at this, we're not looking at any MJ or anything, and maybe it'll feed the jet stream, but we think whatever happened here was a extremely rare anomaly. We don't really expect it to happen again, but we'll stay open to the possibility, because one thing for sure is when you think you know everything, you don't. Clearly you don't. And I'll be the first to say I'm always open to learning something more. So we'll keep our eyes on this. But I don't believe that anything's really going to happen from a swell production standpoint. Let's overlay the MJO. All right, so here's our active phase, the solid contour. Our active phase of the MJO, you can see it moving from west to east. Kelvin wave generation area starts right about here. The dotted contour, the building inactive phase of the MJO. Notice these easterly anomalies are forecast and associated with the building inactive phase of the MJO. That's supposed to last into about the end of March. And then we have another active phase, supposedly with a better bit of westerly anomalies trying to take hold. And see, even this active phase here got some traction with westerly anomalies. It sort of suggests to me that La Nina is losing some of its punch. The more the active phase sets up, the more it erases these easterly anomalies, the better off we are. You want to see westerly anomalies in the West Pacific if you want surf. Now, we don't expect that it's probably going to develop as strong as what this suggests here, because this is out a month or more. But there's hope there. And then another weak inactive phase, but with westerly anomalies continuing. Overlay the low-pass filter. Okay, I know this is a bit busy to look at, but the dotted contours here, this is the high-pressure bias right smack over the date line. Okay, that is the La Nina signal with 1, 2, 3, 4 contour lines. So the fourth contour line to die in April. Other runs of this model, like yesterday or the day before, had it like almost a month earlier. The second contour line dying in May. The third contour line, you can see it probably dying out in late May. Okay, fourth contour line unknown. The other thing to notice here is this solid contour here. This is the low pressure bias over the Indian Ocean. We want this to be over here, but when you're in La Nina, they flip positions, so the Indian Ocean gets all the love right now. The good news is, notice, it's the second contour line fading out today, and some runs of the model had the thickness of this right here collapsing sometime in the late March time frame, and then all this drifting off to the east. Hard to know if that's really going to happen or not. Every model run, this thing sort of flops around a little bit, but right now it certainly looks like we're in the peak atmospherically and from a high low pressure bias thing. We're at the peak or just after the peak right now, and hopefully we'll swing in the right direction over the next several months. All right, enough MJO discussion. Let's go look at La Nina and see what's actually happening. All right, we start subsurface. This is subsurface ocean. This is the West Pacific here, East Pacific here. These are the anchors on the TAO buoys, a series of buoys strung across the equator, across the entire Pacific, used for monitoring El Nino. X's are sensors on the anchor lines. The data is relayed up to a central processing facility. You apply a model to fill in the gaps, and you get a profile of subsurface ocean temperatures. This is in centigrade, 28 degrees centigrade isotherm, warm water in the far West Pacific. And lo and behold, the 29-degree isotherm has materialized, suggesting warm water building in the West Pacific. It's been gone for a month or 2 or 3. Anyway, but otherwise, the 28-degree isotherm holding steady at 165 east. No big change there. 24-degree isotherm, it was deeper last week, probably down at 15 meters, something like that, or 25 meters. It's almost fading here. We've noticed that. Well, we'll get into this in a bit, but we think trade winds have built here recently, and that's kind of causing upwelling and causing whatever warm water was building here to fade out. And we were really surprised at how much warm water developed during the quote-unquote supposed peak of La Nina. So, in a way, it was a good sign. All right, differences from normal for this time of year, anomalies. Lots of warm water at depth, all locked in the West Pacific. Where was that? Let's see. There we go. 170 west is right on that line. So the 0-degree line, maybe 165 west. Maybe it's moved just a hair bit. Still, broad area of 4 degree below normal temperatures here in the East Pacific, Central Pacific, lined up around, where is that? Let's go take a look up there. About 140 west, something like that. So a bit southeast of Hawaii. This is all on the equator. There was that broad pool of warm water here at the surface. That's all gone now, or nearly gone. We think trades, again, are building that area. Let's go take a look at another model. Here we go. This is just a higher fidelity model. It runs about a week behind. You can still see remnants of the warm water here, but that's all gone. This was as of February 7th, so it's a week behind. Lots of warm water here. What was that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 4.5 degrees, maybe 5 degrees centigrade. That's a lot of warm water. Again, lined up right around 170 west, not making any progress. So pretty much more of the same. If anything, the difference is temperatures are a little bit cooler here, and we believe this is all but gone now. Sea level anomalies. These aren't temperatures. This is actual height of the ocean surface. You use Jason 3 satellite, strip out the waves, strip out the wind waves, strip out the tides, and we're just trying to see if the surface of the ocean is a little lower or higher than normal. If it's lower than normal, well, if you have strong easterly winds, it's blowing the ocean that way. And if you have cold water at depth, cold water contracts. That'll create a little bit of a divot on the ocean surface here. So -5, 10, little patch of 15 centimeter, -15 centimeter anomalies out to the date line. That's the equator right there. South America, Central America, New Guinea there, Australia. Kind of a strange looking picture, but you get an idea. And what you see is this big triangle of below normal anomalies from Chile out to the date line in the equator, the whole way up into, California or so. Again, this is the typical La Nina type pattern. If you were in El Nino, you see all these reds here. They'd be like piled up off of Ecuador and making a triangle going like that. But clearly, that's not happening at the moment. Upper ocean heat anomalies. All right, so we've looked at this before. This is the West Pacific here, East Pacific here, but we have time going down the chart here. July, August of 2020. You can see the buildup of warm water here. In fact, when I will say the weak El Nino state that we were in March of 2020, almost a year ago, that's warm water. Okay, it faded in April. You see there was literally no warm water. If you want to have Kelvin waves and you want to have favorable surf in the Pacific, you have to have warm water over here so that when the active phase pushes over this way and it generates west winds or at least stomps on the trades, that this warm water can start flowing east like it did there. That's not even really a Kelvin wave, okay? But you see from August on, just cold water temperatures, probably driven, the typically way this happens is strong east anomalies, okay? But what that does is take any warm water that's trying to build here, pushes it all here, and you see, well, this is 1, 2, 3, 4, 5. Oh, and the scale's hiding down here, so we'll have to do it this way. There you go. 1, 2, 3, 4, 5, so 2 to 2.5 degrees above normal. We still have a ways to go to get it even hotter still. It needs to get hotter. The peak of the cold upwelling was around Halloween, something like that. Water temperatures moderating and the coldest waters pushing even further off to the west. You see a little bit of almost normal water trying to build here off of Ecuador, but not enough to really be meaningful. All right, now to the ocean surface. Here's South America, Central America, California hiding up here, Hawaii right there. Okay, the equator, this is, it's kind of a fragmented picture, but you get the idea. So Chile here, a little bit of warm water, but mainly pretty good pool of cold water going from Chile the whole way up to the equator and then off from there. Here is the last little bits of that warm water pocket. That's the Galapagos right there. This has actually built a little bit in the past few days, and there's a couple of pockets of warming anomalies. And see this cool water here that's tracking on the equator. This was all warm water here last week, I think it was. Or maybe it was the week before. Anyway, the warm water is gone. Cool water in control for the moment. But we were wondering if maybe warm water is trying to rebuild here. we're trying to see if La Nina is fading. I mean, that's the general idea. So more about that in a second. But you can also see the big triangle from California out to the dateline, down to Chile. But this little bit of building warm water here in the heart of the triangle, and it's really on the equator, that's everything that matters, it gives us a little bit of hope. And here's where we get helpful. This is the 7-day temperature trend. You know, this 7 days is not much of a trend at all, but we watched this to get early signs of something going on. And last week we had blues. See, there's the last little bit of the blues there. Cooling waters. Now what do we have? Warming temperatures. Now this doesn't mean the water's warm. It just means that it's warmer compared to 7 days ago. It's right on the equator. The Galapagos are right there. It's also warming off of Peru and Chile, and generally has more coverage than it did even 2 days ago. So this suggests that, you know, when we were talking about that warm water pool off of Ecuador, it appears to be trying to redevelop, and whatever the cool waters that were here are getting shunted off and fading in coverage and dissipating, we think. So this might be a step in the right direction. Again, here's the overview. We see temperatures warming. In fact, I wonder if we can... Oh, we can't do... Can we get them both in there? Yes, we can. So they're warming out to 120 west, we'll say. So 120 west is there. So this area right in here is warming. We'd expect to see these two little pockets here fading out, maybe turning yellow in the next couple of days, which would be good. And I want to see it go the whole way out to here at some point. A little bit early in the game for that. But in general, maybe a light warming trend going on here. It's only on the equator that things really matter. I know you see all this warm here. We'll put this back up here. You see all this warm water down here and up here. But that from a... And as somebody posted, and we get comments, you know, and the comments are, it's amazing how one little area, we'll call it the Kelvin wave generation area, from like here to here to here, can affect the entire global circulation, or the same thing for this area in here, the Nino 1.2 region, or the official El Nino 3.4 region, from here, 120 west to 170 west, 5 degrees north and south of the equator. Okay, I mean, it's just this little area here that subtle changes in temperature in the ocean make a huge difference in terms of what the jet stream is doing, what precipitation is doing, what the ability to generate surf, etc., etc. So that's why we're so just on it and looking all the time, because it doesn't take much to change the way the big ship turns. All right, let's move on. And this is the sea surface temperature trend in the Nino 1.2 region, the region right there off of Ecuador, the Galapagos. Temperatures, you can see, were pretty cold there at one point back in November, even right around New Year's. Trend definitely moving in the right direction. 0.187, 187 thousandths of a degree below normal. That's not too much. That's pretty close to normal. You got to be at least half a degree below normal for 5 consecutive 3-month periods in the Nino 3.4 region to declare La Nina, or if it's warmer than a half degree, El Nino. All right, so we're just trying to get back to normal. That would be a good start. In the official El Nino monitoring region, the Nino 3.4 region, temperatures, well, we kind of took a hit this week. Now we're trying to claw our way back up. Still 0.7, 729 thousandths of a degree below normal. So we need to be above this half degree line for quite a while before we get to quote-unquote normal territory. But we're getting tantalizing close. It's a lot better than where we were back at Thanksgiving. All right, so enough of the ocean. The ocean and the atmosphere get coupled. That is, when the ocean gets cold and stays cold in that thin band along the equator, it also affects the atmosphere. So we can look at the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When pressure gets lower in Tahiti and stays lower than Darwin over time, the index goes negative, and that suggests that pressure in the Pacific. Remember that high pressure bias and the low pressure bias we were talking about on the date line? Well, this is another way to sort of gauge that. Right now, the value is positive, 6.72, and has been positive for quite a while, as you can see, but not as strong positive as it was back earlier in January. we're kind of, hey, trying to move towards something normal, but we also have the active phase of the MJO over the Kelvin wave generation area for the moment. So that might be helping things. 30-day average, you take all this data, average it out for a month, 12.46. We were up considerably higher than that. Where were we? In the 17 and a half. Back late January, the peak of all this, we're down to 12.46, still in La Nina territory. And then the 90-day average really takes all the noise out of it, but it's like a 2-month retrospective, so it's running 2 months behind at 14 plus 14.51, nowhere near negative, clearly in La Nina territory. Just looking back here, that's 14.3. Oh, we were at 14.91. What was that, a couple of days ago? So maybe that was the peak of our La Nina, or maybe there's more to come. We'll have to see. But it is a retrospective, but clearly in La Nina territory. The 30-day Southern Oscillation Index values graphed out. All right, so we peaked out a little bit ago. We're down now. This says, we'll call it 14, something like that. Okay, but here is what a very weak El Nino looks like in 2019. Borderline neutral, we'll call it an average of about minus 7.5, which it really isn't El Nino, but something like that. Clearly, we're up in the 12 to 15 range in the past month. Clearly La Nina, but maybe this is the peak. Maybe we're heading down. We'll watch that. That'll give us some indications. And then finally, I won't say, we have been saying the official, but I don't think this is official. This is from one model, the CFS version 2 forecast for sea surface temperature anomalies in the Nino 3.4 region. That's the official El Nino monitoring region. Today, temperatures are 0.45 of a degree, so not even quite in La Nina territory. Forecast holding into April. And then according to this model, bottoming out deep into minus 1.5, a double dip La Nina range as we get into the October-November time range. But this is one model. Other models, let's go take a look. So here's the consensus is both. So here's the dynamic models. Here's the statistic models. All these are El Nino, La Nina models. The blue is, where is it? The consolidated, but the red is the dynamic model consensus. The green is the statistic model average. They're all saying, and here's dead neutral here. They're all generally saying a convergence on dead neutral in so that's May, June, we'll say the July time frame. We can actually go down here and look at the different models here. There's the CFS2. Now, we looked at one that's got not as many filters as what they're looking at here, but this one, well, we'll just look at the consolidated. We'll go down here and look at everything. So the average of the dynamic models suggests 0. That's neutral by, where is that? Let's go up there. That's June, July time frame, okay. And then the statistic models, here we'll look at that. And they're saying basically the same thing. And you can look at this line here and this line here. And wherever they get to 0, which is both in the July time frame and then pretty much holding there, that suggests that this La Nina theoretically is to be over in a couple of months. And the spring unpredictability barrier, we haven't talked about that. We're not going to get too deep into it. That's basically in the spring, the models have a hard time knowing what's going on. So does that one model that we just look at know something that all these don't? I don't know. It's a big question mark. We're not even officially in the spring unpredictability barrier. I think you need to be like mid-March or something like that before we know, and that runs till about sometime in May. So for right now, kind of a question mark, but the encouraging sign is most major models are saying we're done with this La Nina. If that's the case, when it's over, let's say in July, then you add about another 3 months, so July to August, September, October, November time frame, that maybe the global atmospheric circulation will start returning to normal, if that really happens. And then maybe we could eke out a normal winter next winter. I mean, clearly this winter we'll talk about this in a minute. In fact, Okay, so that's this. Let's move on. All right, so if, in fact, La Nina fades out in June, July, and then we have our 3 months for the atmosphere. Remember, the atmosphere and the whole planet circulation is affected by La Nina. So it just doesn't like La Nina ends and everything instantly turns back to normal. No, it's going to take like a couple of months for the jet stream to sort of figure it out, and it's for its changes to sort of settle down into lower and upper levels of the atmosphere, and for everything to sort of line up. It takes a long time for the boat to turn because it's a huge boat we're talking about. But when it does turn, we're saying, well, around Thanksgiving time frame, maybe we'll get a normal winter out of this. Maybe we'll move towards El Nino. Probably not. I mean, there isn't a huge bundle of warm water over in the West Pacific. It'll be interesting to watch the hurricane season this coming summer. If you see a lot of storms starting to really develop over in the West Pacific, and then maybe recurve and start to recurve over into the Gulf of Alaska, then for sure that's a good sign. We don't think that's going to happen, though. But you never know. There's things you can look at to sort of get a long-term outlook. All right, but for the immediate term, there's swell in the water right now, pretty choppy, ugly conditions in California. Still some swell relative to Hawaii as well, and that's supposed to continue for a couple days. Nothing huge, but something rideable. Southern hemi swell for Southern California for probably the balance of the week. That's okay. Take what you can get. After that, looking at the models, probably a bit of a downturn for a while, and then maybe by next weekend or so, the North Pacific will wake up a little bit. But we think we're getting the sense that a springtime pattern is maybe trying to develop. Things are starting to warm up in the Sierra, perhaps. Perhaps high pressure building off the coast of California. That's typical high pressure and over Hawaii, creating strong north winds. You get a bunch of wind swell, a bunch of upwelling, colder water. I mean, the water's pretty cold up north as it is, certainly colder than normal. And then, of course, the long-term outlook, what's going on with La Nina? Well, we got to get out of the we got to get into the spring unpredictability barrier before we can get out of it. But so we're all kind of on pins and needles, waiting to see what's going to happen, but hoping that La Nina is over in that one model we were looking at that's just predicting doom and gloom 6 months from now doesn't come to pass. All right, so that's our video for this week. If you enjoyed the video, we always appreciate a thumbs up. The algorithms seem to enjoy it, and that helps us make a little bit of money, so thank you if you do that. Comments, always welcome. We try to reply pretty quickly, especially weather theory questions or you just don't understand something. Write it in there. We'll try to respond to it, not only in the comments, but provide a little bit more educational detail in the video here. We'll do the video again. Oh, yeah, and anything else, if you haven't subscribed, please subscribe. If not, go to stormsurf.com. We post the link to the video at the top, every page on the site after we post the video. You can view it there. Look at all the weather data there on stormsurf.com as well. Follow along and test your knowledge with the video at the end of the week. All right, so Valentine's Day got a little bit in the way last night, so we didn't do the video. Sorry about that, but some things do take priority in life, but you have it tonight, and so thank you for watching, and we'll do another one next Sunday. We promise, no interruptions that Sunday night. All right, thanks for watching. We'll do it again next week. Be safe.